Okay, hi everyone. I'm the Chief Science Officer of HuggingFace, where we're building open source tools for natural language processing. So in my talk, I'll actually detail all my tools and what we do at HuggingFace. So maybe let's just get started. Let's see if I can share the screen that I want to share. Okay, then let's go. We have about 30 minutes, right? A little bit more?
Yeah, it's up to you.
Okay, so in this talk, I'll start by introducing the recent breakthrough in NLP, which is based on a concept called transfer learning. So if you don't know what transfer learning is, you will learn what it is. And then in the second part, I'll talk about HuggingFace, our company, and the tools that we do. Okay, so without further introduction, let's go. So what is transfer learning? The traditional way you train a machine learning model on a task is that you gather a data set with a few data points, and then you usually randomly initialize your machine learning model, your statistical model, and then you train it on this data set to get the predictive system you will use in production. Now, usually when you have a second task, which can be another NLP task, then you do the same process all over again. You randomly initialize your model, you train it on your data set, and you obtain a model that you will use for production. And the same when you have a third task, okay? All these are separated. And it's a bit strange because that's definitely not the way human learns, for instance. We try to connect all the tasks that we've experienced in our life, all the challenges that we faced, all the things that we learned. We can connect that in what we call using knowledge, in our memory. And we use that to bootstrap learning when we are faced with a new target task. Okay? And this let us get two main advantages. The first one is that we can learn with just a few data points because our knowledge let us fill the gaps between the data points. And the second big advantage is that we can reach usually better performances. Because we don't overfit on this last data set, we are able to understand the underlying semantic of the task, okay? Because we have all this diverse set of experience in our knowledge base. So transfer learning is one way to try to do that for machine learning as well. And if you want more information on what I'll be able to explain today, you can check this very long tutorial we gave last year at NACL, which was a 3-hour tutorial on transfer learning, which is still very much up to date. And there's also a code exercise there, so you can also experiment yourself with a transfer learning model. So there are many ways you can do transfer learning, but the one I'm going to talk more about today, and which is also the most popular currently, is called sequential transfer learning. So sequential transfer learning means that we have a sequence of tasks. So we have a pre-training task, and we need at least 2 tasks to make a sequence. So the second step is usually called adaptation or fine-tuning. And these 2 steps are very different. The first one, we try to gather as much data as we can. Okay, this data might be just kind of related to our target task. For instance, it's just a bunch of like English or I don't know, Chinese data set because we are working in these languages. But you try to gather a corpora which will be as large as we can. And then we will try to train with a general purpose objective to obtain a general purpose model. So this model that we obtain after having trained on our pre-training data set, this model is not specifically tailored to our target task. Okay, so this first step is usually very computationally intensive because we will work on a very huge corpora. And we end up with a model that we want to be able to use in various tasks. So then we have a second step, which is called then adaptation or fine-tuning, in which we will gather a data set which will be a lot smaller, but will be specifically tailored for our target task. So if you're not familiar with NLP, here are a few examples of target tasks, like text classification. Let's say you have a corpus of news articles and you have to classify them among a fixed set of classes like news, politics, sports. So this is text classification. Okay, your model will digest the article and will try to predict the correct task. It can be also like, for instance, sentiment labeling for tweets. And another task is word labeling, where you will try to label each word. So sometimes we call that also named entity recognition. Let's say you have a news article and you will try to label the names of the organization, okay, to try to to identify them, or the names of actors or the names of corporation. Okay, this is word labeling. And question answering is another example where you have a question, you have like a context or like a database of possible answer, and you will try to find the answer in this database. Okay. Can also be abstractive question answering, in which instead of finding the answer in your corpus, you will try to generate the answer like a human. Okay, like if I ask you something and you try to generate an answer from scratch using your knowledge base in your head, which can be in our case the neural network itself. Okay, so you probably know a lot of these general purpose models. The early one were VEC or Glovey are word embeddings. If you've done a little bit of NLP, you very likely heard about these. And more recently, instead of just sharing word embeddings, which are just a bunch of vectors, we use fully pre-trained models as this general purpose model. Okay, so the most recent are the BERT and the GPT family, for instance, by OpenAI. BERT is from Google, Roberta from Facebook. There are a lot of models. I talk a little bit about that later. So let's focus a little bit on the first step so you get an idea of what's happening there. When we want to train this model, we want a general purpose objective, as I was saying. Okay, you want something that can actually teach you general thing about languages. And recently people have been focusing on something called language modeling. So language modeling, the objective that you're trying to maximize during pre-training is actually the probability of the text. So you give the text to the model, and you can reformulate this, for instance, as a product of the probability of the words. And you try to maximize this. So you can see that as, for instance, as you have the beginning of a sentence, you will try to maximize the probability that the model predicts the good ending. Okay? Or you can hide one token in the middle, one word in the middle, and you will try to maximize the probability that the model will predict the good token. Okay? So there are many ways you can reformulate this. It's actually a very versatile objective, this language modeling objective. And people are still exploring what is the most interesting way to formulate this as a training objective. So the nice thing about this, as you probably guessed, is that we don't have to annotate text. Text is itself annotation. So we usually call that self-supervised. And the nice thing is that we can just take any text that we want. We don't need to pay somebody, or we don't need to find a way to annotate this. And what people have been starting to do is basically just to crawl the web and to get large corpora from Wikipedia, for instance, or like for random pages. So the nice thing is that internet is like now one of the basic human resources, right? So in any languages, and in particular in what we call sometimes low resource languages, in many languages we have enough data to train a high capacity model without overfitting. Okay, so this is a very strong thing with comparison to pre-deep learning method where we needed to have an annotated dataset, which was sometimes very hard to do in a wide variety of language. And then obviously English was the main language that was annotated and the rest was not. But now, because we can use unannotated data, it's kind of leveled the playing field for every language, which is great. Now, how does the model look? Okay, we know what we want to maximize to train them, but how do they look? So here's a very quick intro to BERT or GPT model. How does it work to pre-train one? So let's start with BERT. You take an input sentence from your very large corpora. Okay, let's say you've crawled the internet, so you have a lot of sentences, and one typical sentence is, for instance, "My dog is a good boy," that you will find many times on the internet. And you will mask one word in this sentence. So here we mask the verb is, we mask it, and we replace it with a mask token. And the goal of the model will be to try to guess what was the word here. And as you can understand, to guess what was the word here, the missing word, you will have to actually understand how language works. You will have to understand that after noun, you usually have a verb. You will have to understand that dog is a singular, so this verb will be a singular verb. So just by trying to maximize the probability of reconstructing the right token, the model will learn very many things about language. So how does the model do that? The first step is to convert the strings in something that our neural network can process, which is numbers. So first step is to project, so these strings, we convert them in integers, indices in a vocabulary. We have a fixed size vocabulary. I'll talk a little bit more about that later, but for now, just keep in mind we have this fixed size vocabulary. And for each word, we have a vector, okay, which is like an embedding. If you know VERT or Glovey, that's basically the same idea. You have a vector associated to each word. So we convert the words in vectors, but you see these vectors, they don't depend on the context. They are all independent. So right now, if you just have these vectors, it's very hard to guess what should be instead of mask because this vector does not depend on what's on the left or what's on the right. So we want to do that. So how do we do that? We use something called attention. Attention is basically a weighted average of the context. So here the vector associated to mask, for instance, will be replaced by a weighted average of the left and the right context. Okay, and the weights in this weighted average is attention, it's the attention. Now, after that, we have a nonlinearity, because if we have no nonlinearity, it's not really a neural network. It's basically just a linear system that you can reduce to one single matrix. So we do several times these two steps, attention and nonlinearity, and we end up with still a vector, but now you can understand that this vector depends on the left, on the right context, okay? And though the model probably has enough information to try to guess what's missing. So now we just project this back on the vocabulary. We take the transpose of these matrices here, and we project this back on the vocabulary, and we can try to predict the correct class. Okay, in our case, the label is just the missing word. So this is how you train BERT. It's very simple, right? Now there is another way you can train this model, and there is another type of model, which are called autoregressive models. So if you look at them, they kind of look similar, but there is one main difference. In this case, instead of masking a word and trying to rebuild it, we will try to predict the next token given the previous one. So given my dog is, we'll try to predict a, okay? So the main difference, as you can see here, is that we have to mask the right context here. We cannot use the right context, otherwise the model just see the answer, right? You can see the next word is and then there is no task, basically. Yeah? So this model, they are inherently less powerful. They cannot use the right context because otherwise it's not possible to train. But the good thing is that we can have one label per input token. So we have a lot of signal here to train. Because here, obviously, if we mask everything, then we have nothing to try to guess. Okay, so here we have to find a trade-off between how much tokens we mask and how much context we leave to guess the mask token. And here we don't have to do this trade-off because we don't use the right context, so we can use all these training signals. So these are we call them language model or autoregressive model. This is the GPT family from OpenAI, for instance. And this is more like the BERT family. So the GPT family, they are less powerful in the fact that they cannot use the right context, but they have more training signals, so they usually train faster. Okay, now you've seen the model and you've seen how we can train them. Let's talk a little bit about the second step, adaptation. Okay, so we've ended up with this. We've trained our model with our general pre-training objective, but now we want to use it for a downstream task. So I'll show you a bit like how you modify the model, and then I'll give you two very practical examples so you see how we do that. So we hope that we'll get you remember the two main advantages that I was talking in the first slide, which was data efficiency. We hope that here we can use a small fine-tuning data set that will be quite cheap to annotate. And we also hope that we will reach high performances. This is the promises of transfer learning. Now, how do we do the adaptation? It can be more or less simple. In the simplest case, basically in every case, we will start by removing the pre-training task head, which was this pink square that were on the top. In our case, that was just projecting back on the vocabulary. So we will remove that because this is something we used only for the pre-training step. And we will replace that by a fine-tuning head, or like an adaptation head that can be more or less complex. If we're just doing text classification, we can just use like a simple down projection from the inner dimensionality of our model down to the number of class. So it can be just one matrix, basically. If we're doing something more complex, we can have like a full deep learning model on top, or whatever you want. You can basically just use the vectors, the contextualized vector at the end of your transformer as contextualized input. Okay, so here you're pretty free to do whatever you want if you have like a very complex task. But let me show you then two examples to give you good ideas. The first one is text classification. This is the task. Let's say we have some input strings, And the goal here is to try to predict some tasks, to try to predict some classes. So let's say it's like a fact-checking model. We try to predict if the input string is true or false. This is a bit of a toy task, obviously. The first step is that we have to, this should be fully in the blue square here. The first step is to tokenize. So what is tokenization? Well, these models, they are made to be trained on open domain corpora. As I told you, they are made to be trained on the internet, any kind of data. So in the training data, we'll have rare words, we'll have uncommon words. We'll also very likely have typos, mistakes, okay? We need to be able to train these things. So we could put all these words in vocabulary, but then our vocabulary will be crazy huge. It will be like probably 1 million different words with all the possible typos of every common word. Or we could try to replace some rare word with unknown token, but that's also a bit too bad because sometimes like a complex or a rare word have a lot of meaning. It's an important word because it's complex and it's long and it expresses like a deep idea. So we don't really want to do that. So the way we handle that is that if a word is too rare, like for instance, puppeteer here is quite a rare word. If it's a rare word, we split it in subwords. So here we split it in which is quite a common suffix, and we split it in puppets, which is also quite a common word. So we split that until all the subwords part are in our vocabulary, and we take a reasonable sized vocabulary. For instance, for BERT, it's like 50,000 words, okay, which doesn't bring too much parameters in our model. Now that all the subwords are in our vocabulary, you can convert them in indices, which is the number of these words in our vocabulary, and we're ready to feed our neural network, okay? So this pre-trained model, it's just the BERT or the GPT that we saw earlier. And as you remember, its output in the end contextualized the vector. Okay, there is one vector for each input token. And these vectors are like a contextualized representation of the token in this sentence, okay? Given all the context surrounding this token here. But now we don't really want these full matrices. What we would like is just two classes. So how do we do? Now we add the fine-tuning head, okay? So in our case, this fine-tuning head can just be a down projection from this dimensionality here, 4 down to 2. And we need to find a way to like summarize this full sequence of tokens in just one vector. So there are many ways you can do that, but like the simple one can just be to average over the sequence here. So the simplest one, it's actually not a very bad baseline. You can average here to get just one vector here. And then here you just have a square matrices that is 4 on one side and 2 on the other side, and you output 2 numbers, okay? So now this is a bit of a toy example. Of course, in real life, we don't have a dimensionality of 4. BERT is more like 768. So 768 times 2, it's about 1,500 parameters. So as you see, it's not so big in terms of deep learning size, and it's definitely something that you can train on a reasonably sized data set. So let's see one example of reasonable sized data set. This is one example that we used in the tutorial I was talking in the beginning that we gave last summer. So there is a full code base showing you how to do that if you click on the link on the first page. And this is Trek 6. It's a 6-class classification dataset with about 2,500 examples. So 2,500 is not very big in terms of deep learning. If you have like a reasonably sized team of like, I don't know, 6 or 7 or 8 people, it's definitely something you can label yourself in just 1 or 2 days. So it's something you can do pretty much yourself. And you can see 2 things when you fine-tune the model on this, when you fine-tune the deep learning model. You can see the first thing is that after 1 epoch, so quite definitely a small number of examples, just 2,000 examples, we're already over 90% accuracy in prediction, in text classification. So it's very data efficient. And the second thing is that you can see after 3 epochs, this was on Google Colab, which took about 3 minutes. So it's definitely something you can do. We reached an error rate of 3.6, which was at this time the state of the art on this data set. Okay, so it's also give us the high performances we were looking for. So this is one example of text classification, and now I want to give you another example totally different, so you can get the wide applicability of this approach. This is a chatbot, language generation. So here it's a little bit of smart chatbot in that it's supposed to have a little personality. It has a knowledge base. The chatbot is supposed to be an artist with 4 children who got a cat, who like to do exercise, and who love to watch Game of Thrones. And it's designed to be open to be able to handle open domain conversation. Okay, so the user is discussing, hi, hello, how are you? And now the user say, I'm good, thank you, how are you? And we have to answer. And this is the goal we apply from a human. Great, thanks. My children and I were just about to watch Game of Thrones. So how do you do that? There is something a little bit different here, is that we have various type of inputs. We have kind of a knowledge base here. We have the last two terms from the user, and we also have the beginning of the reply if we're generating the reply word by word. So the thing is that our model was pre-trained with just one input. So how can we do that? There are many ways we can actually do that. The simplest way is that we'll just concatenate all these to build a full input sentence. This is something that's possible. It actually works quite well. The second option is that we will duplicate our pre-trained model in several modules that will be fine-tuned to encode each type of inputs, and we'll manage to connect them together one way or the other. So we can experiment this. We had a paper last year at ACL on these things. But basically, the end story is that it works really, really well. This was a competition that HuggingFace participated into now 2 years ago at NeurIPS. And as you can see, this was, I think, the first time that transfer learning was used in chatbots. And we were really, really strongly above the other techniques in terms of automatic metrics in particular, perplexity and things. Now talking about chatbots, I want to highlight a little bit the trends and the limit of the future of transfer learning. Okay? Take a little bit of a step back now that you know and you understand what this is. So there are many trends. You probably have seen a lot of them. The first one that people have been talking about is the trend to make bigger and bigger models. So now having a model over 1 billion parameter is kind of the norm if you want to be state of the art on most of the benchmarks. GPT-3 is 100 billion. Now Google has open source G-Shard, which is 600 billion. And they even, in this paper, G-Shard paper, they try to train a trillion parameter model. And there's definitely people trying to train trillion parameters model at the moment. This is a little bit of a problem, right? The first thing you can see, this is the leaderboard of GLUE. GLUE is a famous benchmark for natural language understanding. And you can see all the teams. There are Google, Baidu, Microsoft, Facebook. And you basically see no small team or no academia also is this. Huh? That's a problem. What is the reason? Well, training these models could cost 100,000 euros at least, and is more actually in the million euros right now. And so this is definitely something that that academia and small teams cannot afford. So there's a big question is what do they do? What is academia's role in today's research in NLP? There's a big question about environment, because this is obviously, this consumes a lot of energy to train. We know that using energy generate carbon dioxide, so there is a lot of question here. And the last one, maybe the most fundamental, is, well, okay, we gain a few percent on the metrics, but do we expect something fundamentally different in our understanding of AI? Do we expect to see like a phase transition towards another way, or like solving the main problem in AI? This is a very open question. And I think François Chollet explained well that it's a bit like building skyscraper to try to reach the moon, right? We're building stuff that are bigger, but there is actually a big question of, will we touch the moon with this approach, or should we build rockets instead? Now, at HuggingFace, we've been fighting for the other way. We've been fighting for more efficient model. It has been led by one of our lead research scientists, Victor San. He's been working first on distillation, which is a technique to reduce the size of a model by training a student model that we try to mimic the teacher model. And it works really well. You can at least divide the size by 2 while keeping most of the performances. BERT is right now, I think, the most downloaded model on the HuggingFace Model Hub, because it's quite a good trade-off between efficiency and performances. More recently, and this is a paper we'll show actually next week at NeurIPS, we've been investigating pruning. So pruning, the idea is that you will take the big model and you will remove the weights. And you can reach very sparse model where you just keep like 1 or 2% of the model, of the weights, sorry, and you still have most of the performances, okay? You have a drop about like 10%, but here we've divided the number of weights by 100, so it's very strong. So this paper at NeurIPS next week is called movement pruning, which is a specific way to do pruning that is optimized for transfer learning. It works a lot better than the other one. It's this violet line here, this line. And now the last option is to do quantization, where you will try to convert the mixed, the full precision floats in integers. And this also works quite well. And last week at TMNLP, we had a competition that we co-organized with HuggingFace on more efficient model, and a team from Microsoft combined these 3 techniques in one model, and they reach, I think, about 200 times faster model and also 200 times smaller. So like very, very strong efficiency improvement. And for instance, if you're talking about money, the cost to run inference with this model on AWS went for, I think from 5,000 euros per big batch to like 10 euros. So this is like crazy improvement that you can get while keeping most of the performances. Obviously, you pay a little bit, but you can definitely find a very nice optimal place where you will have like a very fast model. Okay, now stepping back a little bit, these models, they also still have some problems. They are better than previous model, but they still fail in various ways. They can fail, this is brittleness. They can fail when you leave a little bit the training distribution, when you feed them with examples which are, sometimes the meaning is the same, but like the surface form, for instance, the length of the input is different, and then they are very quickly lost. So this is a big problem. And the second one is called spuriousness. Well, I call it spuriousness. It's the idea that if you have an easy heuristics in your training set, for instance, one word is very often associated to one class, the model will very quickly catch this easy way to solve the task. These models, they like to rely on what we call surface form, which means that if they don't have to understand what's in the sentence, and they can just look at the words, they are very happy to do that. And this is a problem because very often when you quickly label a small data set, you have a lot of this bias, you have a lot of these easy heuristics. And so, yeah, that's still an open problem. That's a problem we're working a lot on at HuggingFace because we think it's a very important problem. Now, there's a limit to text in general. There's a lot of things we don't say actually in text because of what we call the human reporting bias. The human reporting bias is the fact that we don't say obvious things because they are boring to say. So there's a lot of common sense which we just don't write because it's boring. So I usually take the example of the color of a sheep. We usually don't say that sheep are white animals because everybody knows that, like the common sense. But we talk a lot about black sheep, which is an expression to say somebody who stand out actually from a group of people, okay? And so when you ask the color of a sheep to one of these models, well, they tend to be confused and they say, maybe it's black, maybe it's white, and I'm not sure. And they're not sure because it's a lot more common to talk about black sheep than white sheep in text, okay? So this is a fundamental limits to text and to the fact we humans use text. And if you want to overcome these limits, you have to find like smart way, and most of the smart way can involve leaving text only field. And for instance, using a database where you will connect the color white with a sheep, or like using a picture where you can see that these animals are white, or using a human in the loop, the human being here to say, oh no, you're wrong. This is not the right color. So all these are possible options, but they kind of involve to step back from just text, right? And now the last shortcoming I want to highlight is what I call continual or meta learning. In this transfer learning paradigm, we train a very huge model once. It's very expensive, like GPT-3 costed about, estimates are between 6 and 10 million dollars. But GPT-3 was trained last year and it has no idea of COVID, for instance. And this is very stupid because today COVID is probably the most defining aspect of our current life. It's something that's really important. and it's almost impossible to add it to one of these pre-trained models. As soon as you try to add a little piece of knowledge, you have a phenomenon called catastrophic forgetting, which means that your model will basically forget random pieces of its previous knowledge. And it's really hard to control this thing. Just nobody really knows how to control this catastrophic forgetting. So the only way right now is just to retrain a full model, but you cannot pay 10 million per year to update GPT-3, right? We have to find smarter ways to add small pieces of knowledge to this model, just like humans. We can just add some small pieces of knowledge. Well, we try to. Sometimes we are a bit, there are too many things in our head, but we try to add small pieces of knowledge, and we usually manage to do that quite well. But this model, they cannot. This is an open research direction as well. And this is also something we are investigating at HuggingFace. These are the direction we find very important. Now, talking about HuggingFace, I will now switch to the second part, which is more applied, and which is explaining a little bit what is HuggingFace and what are our tools. Okay. So HuggingFace started as a conversational AI company. We were building a game, actually, a chatbot that was quite used by about 3 million users at some point. And while we were building this thing, we actually open source some library that we were creating. So there was a strong idea of creating generative tools, generative tech in AI, in NLP. And so we started to open source some tools we were using for transfer learning. And these tools, they caught up so much interest from the community that after like a few months, or like about 1 year, we were just fully working on these tools and nobody was developing the chatbot anymore. And so we decided to switch. We decided that actually it made more sense to help the community and the research community develop better model, and that at the end, this will actually solve our original question of making interesting and engaging and funny chatbot to play with. So we're now fully focusing on what we call democratizing or catalyzing NLP, and this involves two main aspects. The first aspect is knowledge sharing. This is why I'm here today talking to you, and we also do some tutorials and workshops and conferences. We are very involved in all this knowledge sharing thing. And the second aspect is code or model sharing. So we open source libraries. We try to open source it what we call the right way, which is somewhere in between a full research code, which is a snapshot of a research project, which is very great, but usually if you want to adapt it to your use case, you have to rewrite like a very long script to be able to leverage it. And the other extreme is like production-ready code, where you have just one line. It works very well, but it's less flexible because it's designed for one production application. Okay, we try to find the right balance just in the middle, something that is very easy to set up, but also quite flexible, so that the researchers who are there basically to invent the future, they can like bend it to invent the future. I would also like to break all the barriers between researchers, practitioners, PyTorch, TensorFlow, all the things. We think that these are just artificial barriers and everybody is basically interested by the same kind of thing at the end. So we have three main libraries today that we show you in chronological order. The first one that you probably heard about is called Transformers. Transformers is a library which goal is to provide you with this general purpose model. We provide it with, in particular, the state-of-the-art model for both natural language understanding and generation. We thought about this library to make it very easy to use and fast to onboard. That was from day one, that was the main goal of the library. And we also wanted to make it state-of-the-art, so that it was built for researchers. Now it's also used a lot by practitioners, but originally it was really built for researchers, and they're interested in state-of-the-art because they want to advance the state-of-the-art. Right now, there's a lot of models. Actually, this is already kind of out of date, but we have over 25 architectures. And in each of these architectures, you can load various checkpoints. So there is about 4,000, I think, checkpoints. So in terms of architecture, you see most of the architecture we've been talking about, BERT, GPT, Roberta is like a BERT. Distill BERT is this efficient BERT. We have a very large model like T5 is 11 billion parameters. XLM Roberta is a very good model if you're doing multilinguality. It's a model that was trained in more than 100 different languages. MMBT, we have some multimodal models, and we have generation model BART. Yeah, there's a lot of them. long-former and reformer data model that are more specifically designed to work on very large type of inputs. So a lot of our work right now actually is trying to add some tagging and some way for people to navigate in all these things. We were not really expected at the beginning to grow so much in terms of scope of models and checkpoints. Right now we work a lot on that. Yeah, using the library, I'll let you just go on the GitHub and just see. It's very easy to use, as I told you. And right now we have a model hub on which we are working a lot, which is there to host these pre-trained checkpoints so everybody can share them and reuse them. We have about 4,000 models, and in particular, we have models in many languages. So obviously English tend to be the dominant languages, but we have more than, I think, 200 languages different here. And so you can navigate in this model hub, you can see the models, you can actually play with them live. They are all plugged on a CPU backend. It's not super fast, but you can play with them live to see how they behave, basically, and to experiment a little bit with them. And now our models, we've switched 2 weeks ago on a version system. So they're all like kind of small Git repo, if you want, which is actually exactly what they are. They are kind of small Git repo with versioning and everything. So it's really clean. And basically, this is kind of becoming something like a GitHub, but for model files. Now, this is all at HuggingFace.co. Now, the second library that we open source in January, I think now, so it's about 10 months old, is Tokenizer library. We saw that the tokenization process, you remember this process of splitting the string in subwords and associating to each subword its integer. This process was actually very slow in Python because there's a lot of for loops, and Python and for loops are not very friends. So we decided to rewrote all this main algorithm for splitting words in subwords. There are a bunch of algorithms like BPA, Unigram, all these. We decided to rewrote them all in Rust, which is a very low-level language, but which is also very, very fast and thread safe. And so now you can, using this tokenizer library, it's integrated by now natively in Transformers. It was an option, but actually on Monday, in 2 days, it will become the default. You will have by default tokenizer provided by this library in Transformers. And they are very fast. If you encode like text, you can encode 1 GB in about 20 seconds. So they can go really fast. It's available in many languages, Python, Node, Rust, and we are working on C++ binding at the moment. Well, not us, but somebody from the community is designing C++ bindings. So yeah, the idea is to make it available in a bunch of languages. And very recently, just before the summer, we've open source last library. We thought that data processing and also accessing dataset was quite of a problem in NLP. It was very spread around. You had to find where was this data set, and you had to write the same pre-processing code that basically everybody has been written like 100 times, like to load this stuff. So we decided to open source a library called Dataset that would be a bit like the models, just one-liner to load most of the dataset which are public, and also to load your own dataset. And this library do two main things. Well, it also has some metrics, but this I won't talk a lot about this, but some metrics can also be quite complex to use in NLP, in particular if you're doing generation, you have like smart metrics. So this is also the same idea that you can load these metrics in one line. And basically what this library does is two things. The first thing is that it gives you access. So this is actually quite out of date, but in about 2 weeks, we'll reach 500 datasets in this metric, which will be a lot. And we are doing actually next week a strong sprint to add many datasets with the community. Will be about 100 people adding datasets. So if you want to join, you can, I will post the link later, but you can join our forum and you can join the sprint if you want. So people will be adding datasets in many languages and also non-English languages, and we reach about 500 datasets. So this is one aspect of the library, is that with just one line, this is called load dataset, and with just one line and the name of the dataset, you just load this on your computer and it's ready to be used. And the second aspect is that it's made to be very easy to use and very efficient. So it works with PyTorch, TensorFlow, NumPy, Pandas. As always, we pretty much framework agnostic, and we try to make it work well with every framework. And it's also made to work very well with large data sets. So For instance, earlier training on Wikipedia or like this dataset that are like 10 or 20 or 50 or 1 terabytes was a pain, because this basically blow up your RAM memory. And so this library is made to be just very efficient on this. We have a low-level backend, which is super efficient based on Apache Arrow, which uses zero-code serialization. Basically, you can use your hard drive just as your RAM memory. And this is made to be fast enough so that it's good for doing deep learning. It's a little bit slower than RAM memory, but it's pretty much, it's almost the same speed. So this is the dataset library. This is the full code to actually prepare. Here you see the PyTorch data loader. If you're using PyTorch, you probably know this. And this is the full code to go from the raw glue. This is the MRPC benchmark. This is Santa's classification dataset to encoded, padded, prepared dataset. Okay, here it's ready to be trained. And everything is made to be very visible. We always want to make things like to not hide something that is important. So here you see how you tokenize the thing. You do it yourself. Actually, here we're using a tokenizer from Transformers, but you could use another tokenizer. How you pad everything is made to be very visible, but at the same time quite code efficient. So you don't write always the same boilerplate for pre-processing. So you can check it out. As always, it's open source. It's on GitHub, HuggingFace Datasets, and it's something that we are really working a lot right now with, as I told you, about 100 people from the community. So it's very exciting. And we also have a hub where you can explore the dataset. You can list them. There's description. There is citation, because it's also very important. You can see the models that were trained on this dataset. And you can even, if you click on browse, you can actually explore the dataset themselves. What's inside, how are the features, and how does it look. And this is our last baby. And it's also at huggingface.com. Okay, so I've pretty much reached the end. And for 43 minutes, that's perfect. And if you have some questions, then I'm happy to answer a few of them. If you have, just let me, I was talking about a link to our forum. And can you still see my screen or not?
Yeah. Yes, we can.
Yeah? Okay. So if you want to see the forum and if you want to participate, it's at discuss.huggingface.co. Okay, this is the place here. I was talking about this joint effort to add new dataset in many languages. You can join this thing, which is the thread of all the people joining. It's called Open to the Community 1 week team effort to reach V2 of dataset. Okay, so you will see it in the top threads. Okay, and now if you have any type of question, I'm happy to answer them or to link you to the relevant resources.
Thomas, we have a few questions from the attendees. Let me just read out for you.
Yep.
So one of the question from Niranjan, how often are biases encountered in datasets, and how do you identify and take them out?
Biases, I would say more often than not, they are more like probably the commonality of all the dataset. How to identify them and take them out is still very much a research question. So we actually have a paper that I can't really talk about because it's still in the anonymous blind review process right now. But we are working on that. We are trying to help, and we think there are ways to identify them automatically without having to yourself write down what is the bias. But maybe let's talk about that in a few weeks. Okay, I'm sorry. There is this blind process, in conferences, and I'm not really allowed to talk about my...
Okay, so moving on to the next
question. We will try to make open source tools for that very soon, as soon.
That sounds good. So moving on to the next question, there is a question from Riti. So how efficient is, I think it's NLP in machine translation? I don't know what the...
it's working really well. So actually, I was talking about the model hub. You can still see my screen, right?
Yeah, we can see that.
Yeah. So if you go to huggingface.co, You have the model hub. You can click on model. And here, or actually maybe you can click here, you can find the languages. This is the page I was showing you with all the languages that we have model in. And you can actually, a lot of these models are also translation models. So you can play with them here. For instance, when they have like, let's put translation tag. And let's take one, I don't know, like one of these. So this is Helsinki model. Here you have some information. It's trained to translate from Spanish to English. And you can play with them. So if you want to experiment them, you can try them here. Well, this one was not loaded. Obviously, we have to take a model which is quite used. T5, yeah, maybe. T5, that's translation as well. This one does translation from English to German. So you can play with them. I think today it's the only really convincing technique in translation is deep learning. I don't think there is basically any alternative to deep learning if you want to do translation at a good level. Yeah. So yeah.
Okay, so let me read out the other questions for you.
Oh yeah, now I see there is a question tab. Okay.
Yeah.
Yeah, the chat. Okay, great. Should I answer to the next top one? Is it possible to identify a sarcastic tone from a sequence? Sentence. Yeah, this is very difficult. Sarcasm detection is very difficult. Even for human, right? Sometimes you read a tweet and you're like, is it serious or not? I think this is probably one of the most difficult tasks that we can have in NLP. So, to be very honest, no, I don't think it's really possible. Well, you can have like something, but this definitely is something that we'll probably resolve when we get AGI or like something. It's very difficult. And lemmatization and NER would help. Yeah, I think the task is just really too difficult. All these tasks that involve understanding all the cultural context behind something, they are very difficult to do with neural network models. How many languages have we managed to annotate so far? Yeah, that's a good question. Well, we don't have yet. So for the models, we start to have some good tagging of the languages. For the dataset, it's still it will be finished, I think, in about 2 weeks. But we don't have yet a clean overview. This is still under work. If you join if you join the effort here, like a lot of people have been talking about interesting languages like Finnish, Hebrew. There is also some Tamil. Yeah, there's a lot of. We're really looking for. This is Urdu. We're really looking for non-English language. So if you know, this is dataset for 10 Indian languages. So if you know good datasets, non-English languages, please join the forum, join this thread, and give us the list, and we'll be very happy to add them. And you can even help add them. It's also even better if native speaker add the dataset, because they can really read them and see if it's well added. For me, I have to use Google Translate. So yeah, How do you add a personality to the agent? So for this, what I can share you is that we wrote a paper actually on this, which is called transfer. So if you type in transfer, you will find a paper and you can read it. And there is also a link to the code base. So I can post this in the chat. Yep, there it is. This was the paper with the Reddit competition and the thing I showed you on chatbot. Congrats on the best paper demo. Yeah, thank you. There was a paper on power transformer. Yeah, this one I don't know. Yeah, so EMNLP, unfortunately, I did not have time to read many papers. So I still have a lot of to-do list. Can you elaborate on controllable biasing in BERT in future? Yeah, this is yeah, I'm not sure what you mean. Yeah, there is some way to do controllable generation, but I'm not sure it's what you ask. If you want to do controllable generation, I can actually just point you to something which is yeah, I'm not sure. Yeah, let's move on to the next question actually, because I'm not sure if I listen right now. So how do you add a personality? Yeah, this one I posted. How do we sustain ourselves? Yeah, so that's a very often question that people ask. So we sustain ourselves two ways. The first thing is that last year we actually raised a decent Series A, about $15 million. Which goes fast, but it's okay because we're a small team. We're just 25 people and we don't really want to grow. We think it's nice to be a small team where everybody knows each other and everybody is very senior. Actually, we are also, people ask, we are recruiting, but only senior people. HuggingFace is not a very good place to learn because everybody is very autonomous and nobody really has time to mentor other people. We don't really expect to mentor people. So if you're senior, you can apply. If you know you can work just basically alone on your thing and you know everything, well, at least everything that you need. If you're junior, I think it's better to go in maybe a bigger company first, or where some people have more time to mentor really people. And so the first way we sustain ourselves is just because we raise money. And the other way is that we try to build some product around the open source core. So we think open source is really our DNA. This is really the mission that everybody believes in at HuggingFace. And so what we try to build is some specific things for companies. Basically, we think that there are some aspects around open source where actually companies are interested, for instance, faster model. These are things that are interesting for companies, but not really for researchers. So this thing, we plan to make some product around these things. A bit like, yeah, open core kind of thing. But the core of the company, this will always be free, and this is the main idea, right? There are a lot of companies like that, like Mongo, Elasticsearch. There are a lot of big companies with a very strong open source core, and that's our models. Does a chatbot necessarily needs transfer learning? Yeah, that's a good question. I think right now, if you want to be, for instance, in an academia benchmark for chatbot, academia benchmark for conversational AI, I think all the top spots are using transfer learning. But in real life, it depends, right? In real life, sometimes a good old rule-based system is still the safest thing you can have. So yeah, it very much depends on what is your actual use case. What was the bug that you worked on the most when working on NLP? Oh, I'm working on many bugs. I usually do now the boring stuff at HuggingFace. So I work a lot on the tokenizer, data processing, all these things that are boring for the other people who like to work on models, but who I think are actually key to getting something that works. And if you do applied NLP, you probably agree that basically in the end, it's all about data processing. And so I work a lot on these things. So there's a lot of boring bugs about data processing. Yeah. But yeah, I think step by step, we'll make this easier, we'll make this safer, and in the end, maybe I'll be able to free time to work on more interesting stuff as well. How far can today's NLP be taken to? Well, I'm very optimistic. I think what's happened over the last 2 years was very exciting, and I think there's still some really cool stuff coming on the direction that I highlight in the slides, like memory, having models that are able to update themselves, having models that are smaller, having models that are able to use other modality like speech, like vision. All these things I think are very exciting. Sometimes they leave the field of pure NLP, but I think maybe that's just the future of NLP, is not to be only about NLP, but to be integrated in all the different type of modality. Can NLP understand emojis? Yeah. So actually that's funny, because that was the first open source thing we did, which was called Torchmoji. Torchmoji was a very nice model that at some point I wanted to integrate. I don't know, my screen is still shared, right? Yeah. At some point I wanted to integrate it in Transformers, but it's an LSTM. It was before Transformers, but still, I mean, It's okay. And Torchmoji is a very cool model that was trained on I think 1.2 billion tweets with emojis. And yeah, maybe I can end up on this because that's a nice model. So what they did, this was a model that was developed by friends at the MIT Media Lab. They took these 1 billion tweets with emojis and they masked the emoji. They removed the emoji. And the model was trained from the text to predict what would be the emoji that a human would add. Okay, they selected like I think 64 main emojis. Maybe they still have their nice website. Yeah, here they go. And so the model has this kind of tweet thing, and it tried to predict what you put as emoji. And what they discovered was actually that just by making this task for a model, you had just actually the state-of-the-art sentimental detector that you could build at that time. That was 2 years ago, so not very far. I think it's probably still very, very close to the state-of-the-art. Just by trying to predict the emoji that the human will use, you get like super top sentimental detection. So yeah, there are definitely models that can understand emoji, and they actually today is the top models also for understanding sentimental things, because emojis are a very good proxy for sentiments. Okay, well, thanks a lot for all your good questions. So if you didn't have time to ask your question, or if you didn't have a complete enough answer, please join the forum. I'm very often there. And also the community is very active there around NLP transfer learning. So I post again the link to the forum, and see you there. Yeah, thanks for your question.
Yeah, so first of all, thank you very much, Thomas, for accepting our request.
It's me.
Yeah.
Okay.
Perfect. So Thomas, thank you very much for accepting our request and joining for the session. I think that was a wonderful session. It was very much intuitive. So Vijay and Aditya, if you have any questions for Thomas, you can just ask. Yeah.
Not really, honestly speaking. That was a good session. Thank you for the presentation. That was very well explained. That's what I felt like.
Yeah. Could you explain, why you started open sourcing your models and everything at first?
The main reason at first. So we were a very small chatbot company at that time, and basically nobody was really taking us seriously. And so we thought, let's open source some code to show that we actually are building some stuff. And yeah, that's how we started. I still think it was a good idea, but it definitely changed the shape of the company. Just now we discovered that it was actually much more rewarding than building our own tech. Just actually sharing stuff with people and getting feedback was much more actually exciting than doing just our thing in our little corner, private. Yeah. How big are we now? We are 25 people now. So we are not very actively recruiting, but if you're very good senior people, we always like interested to look at some good profiles. Yep.
Yeah, Thomas, there is one last question. That can you just elaborate on
I can't hear you very
controllable
well.
biasing in BERT in future?
Can you repeat?
Abdul, looks like your connection.
Just a moment.
Yeah.
Yeah. Let me do one thing. I'll just now is it clear?
Yeah, it's better here.
Okay, so the attendee asks that, can you elaborate on controllable biasing in BERT in future?
Yeah, so this was this I'm not sure. So maybe we can take this question to the forum with more details. Yeah, I'm not exactly sure to say.
Okay then.
Yeah.
Okay. Perfect.
Okay. Well, Yeah, I think I'll have to go soon, but that was very nice. Thanks. The questions were really great. And
Yeah,
it was a pleasure to be here.
yeah, it was an honor to have you here. So thank you for accepting our request, and it was a wonderful session for all of us.